Before to start the class, I want to remember you the homework number 8 is due on May 8th. The lab manual is due on May 12th, and the final exam will be available on May 12th or May 13th. And you can take the test either May 12th or May 13th. And today we are going to discuss the chemical equations and chemical reactions and how to balance the chemical equations. In the previous class we discussed about the chemical bonds, and we say the atoms gain or lose electrons through chemical reactions to achieve a state to lower energy. And that state is when the electron configuration of the atoms are similar to the electron configuration of the noble gases. And the chemical reaction forms a chemical bond, and that is an attractive force that holds the atoms together. In this way, when the atoms they stick together, they form a new compound with the new properties. And these chemical bonds can be happen as ionic bonds, and these occur when one atom transfers electron to another atom. Yes. And one example we discussed last time was lithium with a lithium and fluorine. Yes. The lithium, because the lithium has one electron in the last shell, the lithium transfers one electron to the fluorine because fluorine has 8 electrons in the last shell. If the lithium loses one electron, then the lithium will be positive one, yes, will be positive ion, and lithium has this electron configuration is similar to the helium. Yes, it's similar to the helium. But if fluorine gain one electron, then the ion will be negative one. And the electron configuration now is similar to the neon, yes, which is a noble gas. And they stick together because one is positive, the other is negative. Then the electrostatic attractive force is developed between these two ions, and this is the way the lithium fluoride is forming. Yes? Now you had a new compound. And the other way the chemical bonds can form is covalent bonds, and this happens with the atoms share the electrons. And we know they share the electrons to achieve the noble gas structure. And here we had the example of the methane we discussed last time. And this is one more example here. And this is one example for ionic bonding. As we discussed last time, sodium wants to be similar to neon, then sodium needs to lose one electron. And chlorine wants to be similar to the argon, then need to have 8 electrons in the last shell. And this is why when sodium transfer one electron to chlorine to form sodium chloride, sodium became a positive ion, chlorine became a negative ion. And now both are stable, as now as the electron configuration is similar to the electron configuration of the noble gases. Then this positive and this negative ion, they attract and form the new substance, which is the sodium chloride. And in case of the covalent bonding, we had the chlorine. Chlorine has 7 electrons in the last shell. The other chlorine has 7 electrons in the last shell. Then what they doing is they share the electrons. And now when they share the electron, Now they had a electron in the last shell, and now chlorine has similar structure of the argon, which is noble gas and is stable. This is why here we had the happy face. Yes, now they are stable. They are, we can say they are happy. Yes, both the chlorine, and then they form the chlorine gas. Yes, we have here. Then chemical reactions occur when the bonds between the outermost electron of the atoms are formed or broken. Then we know in the chemical reactions, the outermost electrons are the electrons that play a role. What happens is the chemical reaction involves change in matter. Means when that electrons when the electrons of the atoms they transfer or they share and they form a new compound, then they form new materials, and this new material has new properties. It has new properties different from the original ions. Now, how we can describe a chemical reaction? We can describe a chemical reaction using a chemical equation. Then, for example, if we had here we had the two different chemical reactions. In this case, we had the hydrogen gas. This is the molecules of gas react with molecules of the chlorine gas. They react, and they form hydrochloric hydrogen chloride. Then they form hydrogen chloride. Then we can say one molecule of hydrogen gas react with one molecule of chlorine gas, and when they react, then what we obtain is 2 molecules of hydrogen chloride. Yes. In the second examples, we had 2 molecules of hydrogen gas react with 1 molecule of oxygen gas, and then we had two molecules of water vapor. Then we can describe the chemical reaction using a chemical equation. And we can describe the reaction in different ways. For example, we can use words. Then we can say methane react with oxygen to air, carbon dioxide, and water. But we can also say the same thing using a chemical equation. Yes, methane react with oxygen, and then the product will be carbon dioxide plus water. Then the first part of the equation, in the first part of the equation we had the reactants. In the second part we had the products. Also, we can use the sketches to represent the molecules. In this case, we had the methane molecule. Yes, we had the methane. Here we had 2 oxygens. This is why here we had 2 oxygens. Yes, 2 oxygens. And they react to form the carbon dioxide. This is, we had carbon dioxide, carbon, and 2 oxygens, carbon dioxide, plus 2 molecules of water. And this is, yeah. And in all the three ways we can use to represent a chemical reaction is this. They have all the 3 ways is the same. The meaning is the same. Right? Then we have 1 molecule of methane plus 2 molecules of oxygen to get 1 molecule of carbon dioxide plus 2 molecules of water. Then in our case, we will represent the chemical reaction. We will represent the chemical reaction using a chemical equation. Then let's try to identify another part of the chemical equation to know what is the meaning. Then the subscripts numbers, the blue ones, are part of the formula of the substance. Yes, we had here we had methane, yes, and this 4 is part of this formula. This 2 is part of the oxygen gas. Yes, this 2 is part of the carbon dioxide formula, and this 2 is part of the water formula. The italicized letter in parentheses indicate the physical state. Then the physical state can be solid, then we use S in parentheses, can be L, means liquid, like in this case it's liquid, can be gas, then use G to indicate it's gas, and we can use AQ to indicate is aqueous solution, means it's dissolved in water. Then the green one are the coefficients, and these are the numbers in front of the formula, as these numbers are in front. In this case, we say we had 2 molecules of oxygen. Yes, we had 2 molecules of, all we had in front, 2 molecules of water. And usually we had to write these numbers to balance the equation. How we can balance the equation? What is the mean of the balance equation? And the meaning is if the total number of each kind of atoms is the same in one side of the equation and in the other side of the equation. The number of atoms we had on this side of the equation must be equal to the number of atoms or the ions we had on the other side of the equation. And now we need to remember that when we are dealing with the chemical equations. And one example we had here is the photosynthesis, the chemical reaction of the photosynthesis. Then what happened in this case is water react with carbon dioxide and plus energy, in this case is solar energy, to form glucose plus oxygen. And also the reverse equation also can happen, as if we had glucose, yes, if we had plant materials plus oxygen, yes, this glucose react with oxygen and then produce water, energy plus carbon dioxide. Yes, this is when, for example, the wood burns, then this is happening, yes, we get water plus energy plus carbon dioxide. Then let's try to write this equation. Let's try to write this equation using the format we discussed before. Then in this case, we can write, let's write the first equation. We had water, and let me write here, get some space, plus, to write the physical state, plus carbon dioxide, just to write the physical state, and then this we can represent the energy using this triangle, then glucose plus oxygen. And inside the parentheses we will write the physical state in each case. And let's write first here, water usually is liquid, carbon dioxide is gas, then glucose we know is solid, and oxygen is gas. Now the next thing we want to do is we want to balance the equation. Yes, we want to have the same number of atoms on one side of the equation, and the same one of the number of atoms in one side of the equation must be equal to the number of atoms on the other side. And to do that, what is we can write here all the elements are involved in the reaction. Then we had hydrogen, oxygen, carbon as these three. And we can do something like the list here. In this case, then the first part we had the reactants. We can just write R. The other side we had the products. Yes, this is the reactants and these are the products. Then now we need to count the number of atoms we had on one side and the other side. And this part is try and error. There is no rule to do that, to get the same number of atoms on one side and the other side. Is we will play with that. Yes, there is no rule, there is no any method to do that. It's just trial and error system methods. And we had here 2 hydrogens, but here we had 12. Yes, on this side we had 2, here we had 12. Then what we need to do to get 12 is we need to multiply by 6 on this side. I will write like that to identify. Then now we had 6 plus 2 is 12, and we had 12 on the other side, and we will write here. Sometimes we need to change, modify this one, but for now, let's write 12. Now, oxygen. Oxygen, we had here 6, yes, because 6 times 1 is 6, plus 2 is 8. But here we had 6, and we have 8. Then we can write for now 8 and 8. Now carbon. We had 1, but here we had 6 carbons. Yes, we had 1, 6. Then the only way to get the same number of carbon is we need to multiply by 6 here in front. Then in this way we had 6 and 6. But now we need to check again the oxygen, because now the oxygen changed. Then let's do again the oxygen. We had 6. 6 times 2 is 12. Yes, 6 times 1 is 6. 6 plus 6 times 2 is 12. 6 times 2 is 12. Then we had 18 on this side. Let's see how many we had on the other side. We had 6. Yes, we had oxygen. We had 6 here plus. But we had just 2 here. Then what to do? We need to multiply. Because we need 18, we need to multiply by 6. And let's try it again. We had 6 here. 6 times 2 is 12. Now we had 18 and 18. Now this. Then this is the right equation. This is the complete equation of the chemical reaction of the photosynthesis. This is the balance equation of the chemical reaction of the photosynthesis. Then in the photosynthesis, 6 molecules of water react with 6 molecules of carbon dioxide to get solid glucose and 6 molecules of oxygen. And this is, we had here the answer. But how can you tell a chemical reaction is occurring? What observation may you make? Then in this picture we had a clear solution of the magnesium iodide react, yes, magnesium is this one, react with the silver nitrate, yes, nitrate is here. And we can see with these two combined, they produce a precipitate of silver iodide. Yes. Here we can see there is some precipitation. Yes, there is some solid particles there. Here, there is, and also there is change in color. Yes, because both solutions are clear. Yes, then we can see there is some change in color. Then we can say a chemical reaction is occurring if there is any color change, like in this case, if there is a formation of a solid, if there is a precipitation, if there is a formation of gas, if there is bubbles, present in the, if the bubbles are present during the reaction, or the solution gets hot or cold. And here there is few more examples. In this case, we had the colorless hydrochloric acid. Yes, here is the hydrochloric acid is added to the red solution of cobalt nitrate. Yes, to this solution. And then we can see the solution turns blue. Then there is change in color. This is indication that the chemical reaction has taken place. In this case, we had the sodium dichromate is added to the lead nitrate. Yes. And then we can see there is a precipitation. Then this is another indication that is another indication that the chemical reaction is taking place. In this case, we had calcium metals react with water, and we can see bubbles. Yes, there is a gas. Then this is another indication that the chemical reaction is taking place. And here in the last, we had the methane gas react with oxygen to produce a flame in a Bunsen burner. Yes, and this is another indication the chemical reaction is taking place. Now, how can you predict the products of a chemical reaction and their physical state? Then to predict the products and to predict the chemical reaction and balance the equation, we will follow these 4 steps. We'll follow these 4 steps to complete that. Then in the first step, then we want to predict the products. We want to see what is the physical state of each product, and we want to balance the equation at the end. Then the step number 1, we need to identify the type of ions present in the solution. Then to identify the ions present in the solution, we will need to check here these 2 reactants. Yes. Then we will say, we had manganese, we had chlorine, we had sodium, and we know this one is the hydroxide group. Yes, this is polyatomic ion. And we will write here the ions are present. We will write here. We don't want to write any subscript. We just want to write the ion. Yes, we want to write. I want just to line to indicate these are the ions from this reactant, and this is the ions for the second one. The other is we need to identify the charge. If you don't remember the charge, just use the equation sheet I give you. Yes, for manganese, then we will check what is manganese. Manganese is +2. Then we will write here +2. Chlorine, then chlorine is -1. Chlorine is -1. Sodium, then sodium is +1. Sodium is +1. And we know this is hydroxide, is polyatomic ion, and is -1. And all these tables is in the equation sheet. Yes, it's -1. And we have to write here -1. Let me write better. -1. The next thing we need to predict is how these ions will be combined when they react. Then what indication? One thing is you can see this is positive and this ion is positive, they will not attract, they will repel. Then it's not possible, it will be no possibility they combine. Yes, because both are positive, they will repel. And always the positive ion will be combined with the negative ion to form a new compound. And always this negative will be combined with the positive of the other one. And this is the way they will combine. And now we want to write what are the neutral products, yes, we can get from this. Remember, when we write the products, always this is like when we write the ionic compounds, the first is the positive or the metal part, and then is the negative or the non-metal part. And if these two combine, then we will have first the metal or the positive, then we will have this one first, and this one is positive too. And then we will have the other group, and this is negative one. The other product, because we need to predict two products, the other product will be the sodium, which is positive one, negative one. Now we need to check if we have neutral products. Yes, and we had here positive 2, but we had negative 2. Then we need to do something to get neutral compounds. Then we need two hydroxide molecules. Yes, in this way we will get positive 2 on this side, 2 minus 1 minus 2. Here we don't have problem. This part is positive 1, this is negative 1. We have neutral products. Then the final products we will get, in this case, we can write here what will be the products. One will be magnesium. And maybe we can write here parentheses to indicate all the is 2 molecules of hydroxide. And then the other product will be just sodium chloride. Then again, one important thing is you need to be careful. The first must be always the positive ion, means the metal, and the second one will be the negative ion, yes, positive, negative ion. Now we can write the complete equation, because now we know this is the product 1, this is the product 2. And let's write the complete equation in the last part, unless we will complete the first 2 steps. And we had, if we had this, sodium hydroxide, which is AQ, we will get and I will get some space here for the physical state. Let me write this one again. Plus for the physical state. And the step number 3 is we want to find the physical state of each product. To do that, we will use the other table we had in our equation sheet. Yes, we will use this table. Then we want to find what is the physical state of the magnesium hydroxide. And what we need to do is magnesium, and we will try to find the hydroxide using magnesium hydroxide. We had I is this one, is this one, magnesium. This one is I is insoluble, means it's solid. Yes, then and we want to write here we have solid in this case. In the case of the sodium chloride, then we will do the same. Sodium, and we will chloride is A, means is AQ. Yes, it's AQ. We have sodium chloride is A, means is AQ. Then we have AQ. And we're done with the third part. Now we need to check the last part. In the last part, we need to balance the equation. And to balance the equation, we need to see if the number of atoms we had on one side is the same of the number of atoms we had on the other side. And let's try to write here the atoms. I don't have here a space, but probably I will make a space here. Let me write here. And then now we need to write all the, I will do something here like that. It's number 4. And we need to write the list for all the, we had magnesium, we had chlorine, then we had sodium, then we had oxygen, and finally we had hydrogen. And we had the reactants and we had the products. Then now we want to check, we need to get the same number of elements on both sides. And remember this part, the balance, when that part when we are balancing the equation, there is no method, it's just trial and error. And magnesium, we had one here, we had one here, then we don't have problem now right now, then we will write here, it's 1 and 1. We had 1 and 1. The next is the chlorine. Chlorine, we had 2 here, but here just we had 1. Then the way we can fix this one is we can write 2 here in front. This way we had 2 here, we had 2 here, and 2 times 1, because we had 1 chlorine here, 2 times 1 is 2. And we had 2 and 2, and we will write that here. The next is the sodium. Sodium, we had 1 sodium on this side, we had 1 here, but we had 2 here. When we need to do something to get 2, then to get 2, just the only way is we multiply here by 2. And now we had 2 sodiums here, 2 sodiums, then we write 2 and 2. Oxygens, let's see. Remember this 2 is multiplying the whole molecule. As this 2 is multiplying sodium and the hydroxide group. Then 2 times 1 is 2 oxygens, and here again, here this 2 is multiply everything we had inside, then we had 1 oxygen, and here we had 2, then we had 2 oxygens. Yes, we had 2 oxygens on this side because this 2 is multiplying everything, and here we had 2 oxygens. Then we will write here, no problem, we had 2 and 2. Now hydrogen, remember these 2 multiply everything, then we had 2 hydrogens on this side, and on this side we had 2 hydrogens. Then 2 and 2. And this is the equation. This is the balance equation of this reaction. And these are the products we predict. Yes, if these two compounds react, we can predict we will get these two new compounds. And let's try one more example. And we want to predict if the calcium chloride react with the sodium carbonate, what will be the products? And in the problem say we must get 2 products. Yes. And let's follow the 4 steps to solve this problem. And the step number 1, we need to identify the ions present in the solution. And let's go with the step number 1. And we need to identify the ions. We had calcium. Remember, when we identify the ions, we don't write the subscripts. We don't write these 2. And here we know we had sodium, and the other is the polyatomic ion, is carbonate. And this is 1 unit. Again, if you don't remember what are the charts, just you can check in the periodic table or in this table in case of the polyatomic ions. And we need to calcium. Calcium is +2. And we will write here calcium is +2. Probably you know now chlorine is -1. Yes, chlorine is -1. Is there. Sodium is +2. Sodium is +1. And carbonate is -2. Yes, sodium is +1 and carbonate is -2. Sodium is +1, -2. And now we know what are the charges for each of these ions. The next thing we want to know is how we can combine them to get neutral compounds, yes, neutral products. And now we know calcium cannot react with sodium because both are positive, they will repel. Then this must be react with the positive, must be react with the negative, and in this negative must be react with the positive. Then let's write here the products, yes. Then first always the positive ion and then the negative ion. First always the positive ion and then the negative ion. Remember, you had to check if you had neutral products, and in this case we had +2, we had -2, neutral, +1, -1 is neutral. Then the final products we will get is, remember, when you write the products, you don't need to write the charges, yes, because you need to get neutral products in this step. Then these are the products. One product, yes, this product is this one, and the second product is this one. Then now let's complete the step number 3 and step number 4. Now let's write the complete equation because now we know the products. Then we had calcium chloride plus sodium carbonate, AQ, and we will get calcium carbonate, and we want to get some space here for the physical state plus sodium for physical state. Now we need the next step number 3. We need to find what is the physical state for the product, and we know for that we will use this table we had in our equation sheet, where calcium carbonate. And let's go here. We had calcium carbonate. This I means it's insoluble, means it's solid. Yes, calcium carbonate is just here. Yes, and we know this one is solid. Here we have solid. And sodium chloride. Then we had sodium, and we need to find sodium chloride. Is A means is AQ. Yes, it's here. Then we do one right here, AQ. We're done with the step 3. Now we go with the step 4. With the step 4, we need to balance. Remember that for this part, what we need to do is we need to play. Yes, we need to play with the numbers to see how we can get the same number of atoms on both sides of the equation. Then let's write all the atoms we had present is calcium, we had chlorine, we had sodium, we had carbon, we had oxygen. And here we had the reactants, we had the products here. And so now Then let's start with the calcium. We had one calcium here, we had one on the other side. Yes, we had one here, and one here, one here. Now chlorine, we had two here, we had one here, then we had two, we had one. Then we need to multiply here by 2 to get the same number. Then 2 and 2, now we solve that problem. Yes. Sodium. We had 2 sodiums here, and we had 2 here. Remember, these 2 multiply the whole molecule. Then we had 2 times 1, we had 2. Yes, we had 2 sodiums. Carbon, we had 1 here, and we had 1 here. Oxygen, we have 3 here, and we have 3 here. Then it's balanced. Yes. And this is the complete chemical equation for this reaction. Yes. And if these two substances, these compounds, they react, we expected to get these two, yes, carbon, carbonate, and sodium chloride. And let's now move to the next example. In this case, we want to predict the products and find the physical state and balance in the equation if the calcium carbonate react with the hydrochloric acid. And we expected 3 different products. And let's see, we will follow the 4 steps. And step number 1, we want to find what are the ions we had in this compound. Then we had calcium. We know this is polyatomic ion. This is 1 unit. This is hydrogen, and this is chlorine. Now we need to see what is the charge. Yes, carbon. And last, let's go here. Calcium. It is calcium. Calcium is +2. Then we will write calcium is +2. Carbonate -2. Yes, it's here -2. Hydrogen we know is +1, and chlorine is -1. Yes, so hydrogen is +1, chlorine is -1. Now we need to predict the neutral products. Step 2. And we know how they will combine. The positive will be combined with the negative. Yes, always, because if both are positive, they will repel. This combined with this one and this. This combined with this will be combined with this. Then always the positive will be combined with the negative, and here also the negative will be react with the positive. It's the only way they can form a new compound if they had opposite charges, because they will attract. Then now let's predict the neutral compounds, the neutral products. And let's write here the first one, always the positive first, and the negative will be the second one. Here will be hydrogen first, which is +1. This is -2. Now we need to get neutral products. Then we had here +2, -1 is not neutral. Then how we can get neutral is we need 2 chlorines, yes, because here we had +2. 2 minus 1 will be -2. Yes. This 2 times -1, -2. Now we had neutral products. Then in the second one, we had +1 here, and we had -2 here. Then there is no neutral, then we need to do something to get neutral, then we need to multiply here by 2. Two times 1 is positive 2. This is negative 2. Yes. Then remember, this 3 is part of the formula. Yes. Then we don't multiply by that. Then it will be positive 2. Will be positive 2. Will be negative 2. Now we have neutral product. And let's write the product. Remember to write the final product. We don't need to use the charges as we write. But here we need 2 chlorines. This is why we need to write. Here we need 2 hydrogens. Then these are the top 2 products. But here in the problem they say they expected 3 products. And the thing is, usually these molecules is not going to appear like that. This is going to appear like water plus, okay, and this will be appear like water plus carbon dioxide. And now is we have the 3 products, 1, 2, 3 products, and you can see here is the same. We had the same number of atoms. We had 2 oxygens here, 2 oxygens, 1 carbon, 1 carbon, 1 plus 2 oxygens. We had 3 oxygens. Yes, is usually the way appear this molecule is like water plus carbon dioxide. Now we had the 3 products. We had 1 product, 2, 3 products. Let's write the complete equation and let's write the full equation and complete the 2 steps. And we had calcium carbonate, hydrochloric acid, which is AQ, and we should get calcium. Let me get some space here. Calcium plus now step number 3, we want to find what is the physical state. Then calcium chloride. Calcium chloride is A, means is AQ. Yes, calcium chloride. It's AQ. Water usually is liquid, and carbon dioxide is gas. The next step is we need to balance the equation. To do that, we had to list all the elements in the present in the reaction. Then we will see how we can get the same number of atoms on both sides of the equation. Then we have the reactants, we have the products here. Let's see with calcium. Calcium, we had 1 here, we had 1 here, then 1 and 1. Carbon, we had carbon, let's see, we have the 1 carbon here, we had 1 here, then no problem with carbon. Oxygen, we have 3 oxygens here. We had 1 plus 2, we had 3 oxygens. Yes, then no problem with oxygens. Now hydrogen. Hydrogen, we had 1 hydrogen here, but here we had 2 hydrogens. Then we need to multiply by 2 here to get 2 hydrogens. Yes, and now we had 2 and 2. Now the chlorine, we had 2 chlorine here. Yes, 2 times 1 is 2, and here we had 2 chlorines. Then this is the the complete equation for these chemical reactions. In the last example, we had hydrogen acetate plus sodium carbonate, and we want to know if these two compounds react, what will be the product we will have. Then, according to this problem, we must have three different products. And let's try to follow the 4 steps to try to predict the products and to write the correct chemical equation for this reaction. And let's try to start with the step number 1. Then if you don't remember, because this looks like long unit, then just you check in your polyatomic ions if you had something like this one. Yes? Then, and this, if you check the polyatomic ions, you will see this correspond to the acetate, and this is -1 charge. Yes, it's -1. And we know this is one. It's like at like 1 unit. Then we had hydrogen. Then we had the polyatomic ion. And this is at like 1 unit. And then we had sodium and carbonate. And one thing I want you to check is, you see, we need to write these numbers here because this is part of the formula of the acetate. Yes, this is why we need. But in this case, you see the sodium, this telling how many times you had sodium. This is why we don't need to write these 2 here. Yes, because this 2 is telling you need 2 sodiums to get the neutral component in this case. And we don't need to write this 2. If the subscript is part of the formula, we must write. Yes, but here this 2 is telling you had 2 sodiums, then you don't need to write this 2 here. Now we need to check the charge for each ion. Then hydrogen, we know is +1. Let me write better. For acetate, we know is -1. For sodium is +1. And for carbonate is -2. Remember, if you don't need to memorize the charges, you had this with you, yes, then you can always check what is sodium, what is the acetate, what is the other one we had here. We had the hydrogen and we had the carbonate. Hydrogen is +1 and carbonate is -2. Then you had this one, you will have this one with you, yes, you will have the equation sheet. You don't have to memorize all these charges. What you need to know is here how you must combine them. Then they will react, the positive must be react with the negative ion, yes, and the negative with the positive. Then now in the step number 1, we need to predict the correct products. Yes, the correct products, and important thing, the product must be neutral. Yes, and let's write the first one. The first one will be hydrogen. This must be +1. This is -2. Remember, the positive one must be first. Then sodium. Sodium is +1, and then we had acetate. Then we want neutral compounds. Then we had here 1 hydrogen, 2 carbonate. When we need neutral, then we need to multiply here by 2. Then 2 + 1 is +2, and we have -2. It's neutral. And here we don't have any problem. This is +1, this is -1. is neutral. Then just now we write the final products we had. In this case will be, this is one, and the other one will be, let me write here. But remember, we need 3 products. Here we have just 2. But remember this one, we can write like water plus carbon dioxide. Now we can write the final equations. And we need to complete the step 3, which is we need to write the physical state for each compound, for each product. And let's write here the equation. 2 oxygen, and this is AQ plus this solid. Now we need to write the 3 products. We need to write here the 3 products. One is, the other is, and the last one is, this is long one. Let's see, we have space here. I will write here the physical state. Then we had here water, we had carbon dioxide, we had sodium acetate. Yes. And here, I maybe stay here is 2, and here also is 2. Yes, I change the number. Here is 2. Yes, 2, 2, 2. I think the other part is 5. Yes, no problem. Then the next thing we want to predict is the physical state for the products. And we know the water usually is liquid. This is L. Let me write better L. L. This is gas. And now we need to check the sodium acetate. Here will be sodium acetate will be A, maybe will be AQ. Yes, sodium acetate will be A, and A means AQ. Here will be AQ. The next thing we want to do is we want to balance the equation. And let's here write all the atoms that are involved in this. Will be hydrogen, will be carbon, oxygen, sodium. And now we had on the first part the reactants, and then we had the products. Remember that we don't have any rule to do this one, but you see we had here hydrogens. To start with hydrogens, we had hydrogens. We had 4 hydrogens here, and here we had hydrogen here. Hydrogen is a little complex because we had hydrogen in different parts of the equation. Then if this happens, then what I suggest you is you can check first another element that appear just in one place in each side. For example, we had sodium. Sodium appeared just here and just here. On this side we had 2 sodiums, yes, but here we had 1. We must multiply here by 2. It's the only way we can get 2 sodiums, yes. And this is easier than to guess how we can balance the hydrogen, because hydrogen appear in different parts here of the equation. But for sodium is easier because we know we must multiply. There is no any other option. We need to multiply here sodium by 2. And this we need to, let me get more space here. We need to multiply here sodium by 2. Yes. Then if we multiply by 2 here, we will get 2 sodiums, 2 sodiums. Then you can do in any order. This one is you will do in the way is easy. And let's see now. We will try it with hydrogens now. We had 4 hydrogens. Yes, we had 1 plus 3. We had 4 hydrogens on this side. But here we had 2. 2 times 3 is 6. Yes, 2 times 3 is 6 plus 2 is 8. We had 8 hydrogens on this side, and here we had 4. Then we need to multiply by 2 here to get 8. Then we need to multiply by 2 here to get 8. It's the only way we can get 8 hydrogens on both sides. Yes. Now 2 plus 4 is 8. 2 plus 6 is 8. And then we will take care of the others now, the other elements. Then now we had 4 carbons here, plus 1 is 5. Yes, 2 times 2 is 4, plus 1 is 5. Let's see how many we had on the other side. We had 1 here, but 2 plus 2 is 4, plus 1 is 5. We had 5 and 5. Then no problem with carbon, we had 5 and 5. Now oxygen. We had 2 plus 2 is 4, plus 3 is 7. Yes, 2 plus 2 is 4, plus 3, 7. Now let's check on the other side of the equation. We had 1 plus 2 is 3. Now 2 plus 2 is 4, plus 3, 7. And let's do again this part. 2 times 2 is 4. Here we had 4 oxygens, plus 3, we had 7. Let's see on the other side. We are doing this for oxygens. Yes, now for the oxygens, we had 1 plus 2 is 3. 2 plus 2 is 4. Then we had 7. Then it's right. We had 7 and 7. Then now, this is the equation. If these two compounds react, we will get these 3 products, and this is the balanced chemical equation. This is all I had to discuss today.